Well, so let's get started. If you look at nowadays, the amount of data getting generated, okay, amount of data that's getting generated is very, very, very huge. Right from your mobile phones, systems, sensors, satellites, your road signal, everywhere the data is getting generated, and the storage cost nowadays, like it has got reduced drastically. The storage cost has reduced drastically, as well as we have enough computer power to analyze and find the information within the stored data. Earlier, what we used to do, whatever the data that we store, only for the legal purpose or the government mandate, we will be storing the huge amount of data, and only for whenever that is required we will go and analyze the data. Nowadays the trend is totally different. Within that, whenever the data is available, I can analyze the data, identify what happened in the past, as well as I can predict what is going to happen in the future. I'll come to that, what type of analytics that happens. I'll come to that. Before that, whenever I say the amount of data that is coming in, the type of data that is coming in also got changed extensively. Earlier, when we say data, it will be there in the database. When we say data, it will be there in the database, well organized, a structured data, we will be having it. And nowadays, we are having huge amount of unstructured data. Assume like you have a traffic signal, like n number of traffic signal across the country. What I am going to do to enforce the red signal, I'll be having the camera and I'll be taking the snaps of the signal at that point of time. Whenever the car, whenever the signal gets turns to red, I'll capture the photo and I'm going to analyze it automatically by the system, and I'm going to issue tickets to those vehicles. Already it's implemented in few signals within US and few counties it's already implemented. What we are doing here, we are analyzing the images. There is no structure within the image. By looking at the image, I need to identify whether that vehicle violated the signal at that point of time or not. If violated, what is the number plate? Identify, recognize the number, and then get the output. Okay, here like the data is like totally unstructured. I cannot do anything like a database, select star from this and then get the information. Right. So we need to ha have a mechanism to handle the unstructured data as well. A simple example, assume like the amount of data going to get collected from the engine, the flight engine. Every hour will be generating 2 terabytes. If a flight having two engines, imagine the amount of data. And let's consider an average um, flight hours of a particular flight to be 6 hours, and total number of commercial flights in the sky in a given day in US is around 28,000. So in a year, we will end up generating this much amount of data. If I want to analyze, find out, predict what is the engine behavior, how is it going on, what's happening, everything I can do it with this huge amount of data. And when I say huge, it's really, really massive. So I need, let's get into our whiteboard. I need a mechanism to handle how I am going to store this huge amount of data, how I am going to verify the cleanliness of this data, how I am going to process this particular data. The answer to the question how is going to come from this big data technology. This is what we are going to see today. Okay, and okay, I'm having data for like say 10 petabytes or like 100 petabytes of data. Where I will be storing it, where I will be processing it, right? The answer to the question where, that will be answered by the cloud. There are a lot of cloud providers like Amazon Web Services, Microsoft Azure, Google Compute Cloud. There are a lot of cloud providers who is going to give me the answer to the question where I am going to solve the business problem. And the next question I'm going to answer is the data science. That's the what part of it. What I want to identify with that huge amount of data. After collecting like say 10 petabytes of data, what I'm going to analyze, what information, what insights, or what pattern I'm going to find. That's where the answer to the data science is coming into picture. Okay, that's why the answer to the what, and data science is going to answer that particular question. Okay. So all these three together, big data, cloud, data science, all these three together going to give me the solution or create a magic triangle or a sweet spot where I can solve the business problem, which is going to be very fruitful, and it's going to be very useful solution or useful insights I'm going to get. Okay, a little bit about how cloud things works. We will see in our traditional world. Okay, assume this is a computer system. Assume this is a computer system. I'll have some amount of memory, some amount of processor, and some amount of hard disk for storage. Right? If there is a more demand to get more compute power or more storage or more memory, what I'll be doing? I'll add more resources in the same machine. Right? That is called vertical scaling. Generally, I'll go with the vertical scaling. I'll add more hard disk. I'll add more. Okay, I'll add more memory, or I'll add more processor. Right? Now, here, folks, please hold on with the question. I'll complete the this one and I'll take up the question at the end. Okay, so that all the dots will get connected. Okay, of course, I wish to answer everyone's question. Okay, let's take up the question like around like 20 minutes of the session. I have reserved it for the QA session. So I'll take up the question at the end so that everyone's question will get answered, as well as we will not have any break in the logical flow of the discussion. Right, folks? Okay. Now, Abhishek, your question will also get answered down the line. It's going to get answered. Okay. Why the traditional database cannot solve the problem? Okay. All right. Now, beyond some limit, okay, adding more and more resources to the individual machine is called vertical scaling. Vertical scaling always cannot satisfy most of the problem statement. Assume like if I want to store 2 terabytes of data, I can have 2 terabytes hard disk in one single machine and I can store. If I have to store 1 petabyte of data, say like 1000 terabytes of data or like 2000 terabytes of data, one uh, system cannot handle it. One system cannot handle everything, right? For that, we will be going with a problem statement. We will be going with a mechanism of horizontal scaling. What I'll do, I'll add more and more machines in parallel. Say 1000 machines or 10,000 machines, 1 lakh machines. They will be working in parallel together simultaneously, and I'll be adding more and more machines parallel. That's called horizontal scaling. Within horizontal scaling, there is no limitation, and most of the cloud supports horizontal scaling. What I'll do, I'll add n number of machines in parallel. Assume if I need to store 2000 terabytes of data, if I have each machine, if it can support, okay, each machine if it can support 2 terabytes of data, I can, if I have 1000 machines, easily I can store 2000 terabytes of data. That is like a distributed way of storing the data. Here we are talking about the distributed computing. Now, I'm just going to put a small problem statement. Okay, small problem statement. You guys are provided with, say, 2000 terabytes of Twitter information. Assume like you collected all the tweet information that happened in the last 1 year. Okay, all the tweet information that happened in the last 1 year, you are going to collect, and the volume of data that we have is 2000 terabytes. The first problem we have is storing that particular 2000 terabytes of data in one place, right? 2000 terabytes of data in one place. And the next thing is I need to process and identify the 2000, what is the insights available in that particular Twitter information. Okay, how the sentiment of people oscillated in the last 1 year about Narendra Modi or about the government or other state, what people think, or any national schemes that is introduced, okay, or any product introduced in the globe, how the people think about, for example, what is the sentiment of people analyzed or like it oscillated across the globe in the last 1 year. I want to process that 2000 terabytes of data. So the next problem I have is processing huge amount of data. I'll come to the transfer problem later. Okay, to solve the storage problem, what I can do, I can use distributed storage. I can store huge amount of information by distributing it into across n number of machines, and I can get the problem solved. Again, for processing, if I'm going to process 1 KB per day, 1 KB record, and if I'm going to process, the processing capacity what I have with me is 1000 records per second. You know how much time it's going to take to process 1 terabyte of data? Approximate guess? It's going to take around 277 CPU days. The same way, to process 1 petabyte of data, it will take 785 years. If I'm going to 1 petabyte is 1000 terabytes, right? And if I'm going to spend like such a long time to process the information, it's totally useless. Even like if the information is available 1 week down the line, right? 1 week delay, it's going to be really, it's not going to be useful at all. I want the information as quick as possible, right? The same way, what generally we will do, I'll be having the data in the database. If I want to analyze or any storage area, if I want to analyze the data, I need to bring it to the compute unit where I'm going to process or analyze to my business intelligence tool, BI tool, or any analytics tool. I need to bring the data. How I'll be bringing the data? I'll bring it over the network. Right? Network is a huge bottleneck. It cannot transfer the data beyond some limit. Right? Even if I have such a huge massive cluster, if I'm going to transfer such a huge amount of data, right, I'll end up bringing it I'll end up spending 2 hours for every 1 terabyte of data, right? And for 1 petabyte, I'll spend 83 days. The same way, I have 2000 terabytes. There is 2 petabytes of data. I'll spend around 150 to 160 day to bring the data. 150 to 160 day to bring the data to my compute area and then do the compute. So all these 3 problem needs to be addressed. We can easily address this storage problem by distributing the storage across multiple systems. And processing problem also I can address it by distributing the processing. Instead of having one machine, I'll have 10,000 machines, or I'll have 1 lakh machines, 100,000 machines doing the job parallelly for me and get things done. Nowadays the clouds are very sophisticated, like Amazon cloud. Even getting 100,000 machines is not a huge job. I'll pay for what I want, what I am using, and get the things done, right? Well, so the only biggest problem that is in front of us is the transfer problem that we need to address. That we will see how we are going to address that specific problem. Okay. And before that, let me just give you guys like another analogy. You guys may question or wonder like, am I really going to have 2 petabytes of data or like 2000 terabytes of data? Are we into that particular environment? Are we into that particular world? Yes. To answer your questions, I hope some of you guys would have heard about this particular website called Skybox Imaging. It was acquired by Google very recently. What they do, they have their own satellites, high definition satellites. They'll take snapshot of the Earth from the space. No visa required in space, right? They'll take the snapshot of the Earth and they'll analyze what is the, for example, harbor. Assume like I'm going to take the snapshot of the, okay, let me, here itself you'll get it. I'm going to take the snapshot of the harbor. Okay, I can identify, assume this is the harbor, I can identify what is the utilization of the boats that I have parked. What is the utilization? Or assume like orange fields in California. From the space itself, by looking at the color of the orange fields, I can predict what is going to be the yield of oranges from California this year. If I know that particular information well in advance, I'll be the king in the market, right? I can go and do all hedging, whatever the tools available in the world, the market, I'll use them. I'll be the king in the market. The same way, for example, the harbor, what is the container utilization? Okay, well, how much amount of container is being stored in the harbor, how much is space available, all such things, or paddy field in India, everything I can look from the space, I can predict. You may ask the question, can a system understand this? Can a system understand the images? Yes. That's where the data science comes into picture. That's where the data science comes into picture. What is data science? Assume like I'm having 100 images. I am providing 100 different type of images. Each image, for example, one set of image is the human face. Um, Other set of image is some images, animal faces, and another set of images like the bird's face, bird's image. If I ask you guys to separate them into different categories, okay, how many images will be Assume I'm having 100 such images. I'm having 100 such images. Three different categories of images: human faces, animals, and birds. If I ask it to separate them into different categories, how many categories you guys will make it? If I split those images, group those images into different categories, you'll end up making three groups, right? Exactly, you'll end up making it into three groups. Now, if the same input, okay, if I give the same input to a computer system and to categorize it, can a computer system can understand? No, right? Now, let's assume I'm going to give the same input, same set of images to a kid, one or like 2 or 3 years old kid. Can the kid do it? Separating, like, okay, we can do it very easily with the three different groups, but at the same time, a 1 year, a 2 year old kid, can they do it? No. But if we teach them how what this particular, this is like, this looks as like a human faces, this looks like a bird, you look at their wings, everything, right? They can very well differentiate them. At the same time, after learning, if I ask them to categorize these images, maybe out of 100 images, 80 or 90 images they may categorize it properly. The remaining images, like, they may make some mistakes. For example, kangaroo, like, which looks very, or penguin, which looks like an animal as well as like a bird, they may make some mistakes, right? The same way, I can teach the human computer system to understand the unstructured data, right? Everywhere there we will be talking about vectors, machine learning, everything, vectors and matrices. That particular area is called machine learning. Within the data science field, that particular area is called machine learning. Making the system to understand what's going on, okay? Making the system to understand the data. How to identify? There are n number of algorithms available, not only audio, videos, everything, n number of algorithms available to analyze the audios, videos, everything. Assume I am having 1 million MRI scanned images. Okay, 1 million MRI scanned images. If I'm going to identify a pattern, is there any anomaly existing within that MRI scan? Instead of depending on like human verification, if a computer system can do, then it's going to be really very great, right? But we need to teach the system how to understand this particular image. Teaching the system or making the system aware of the data or the pattern and how to understand the particular data and what I want to analyze, that is called machine learning. There are a number of algorithms, huge number of proved algorithms available. It's a huge different version by itself that will come in the data science and machine learning part. And data science and machine learning is not a new technology that's existing for decades. Even 3000 years back, Egyptians, they were using the data science or like some algorithms to predict what will be the what will be the flood amount of flood that will happen in the Nile River, all such things they were predicting it. Okay. And in 1940s 50s period, they were using like papers and pencil, like a number of algorithms, and they were using single system, Excel, all such tools they were using. Now the amount of data we are talking about is really really massive. I want to identify, everything is like in petabytes or terabytes of data, so I need a mechanism to handle how to store or how to process such a huge amount of data. That's where this big data technology comes into picture. Okay, sorry. And the data that I'm going to get, it could be in different forms. One is the volume. I may get like terabytes or exabytes or like huge volume of data. And I may be in a position to process like huge velocity of the data. That is like the amount of data that's going to come in will be very, very, very huge, right? Assume like I have installed 100,000 cameras across the signal, 100,000 camera across the signal. Look at the amount of video stream that's going to come across the signals, or the snapshots that I am going to take at every time when the signal getting turned from green to red, right? The volume will be, the velocity, the speed at which the data going to come in will be very, very huge. And I need to handle like varieties of data. The data I'll be getting will be in different forms, sometimes like audios, videos, text, everything I may get. So I may need to handle such varieties of data. and I need to handle the veracity. Veracity is about the uncertainty or the cleanliness of the data, how much I can trust that particular data, right? The cleanliness, the veracity of the data I need to handle. IBM, they defined the three V's. Generally in big data world, the three V's will be defining the characteristics of big data. Sometimes few people, they say, like, they argue veracity should also be included as a part of characteristics. Few people argue saying it is not a characteristics of a big data, it's a characteristics of the data, just the data, right? It's not about the big data. So this veracity, that's why it's mentioned with the star. So let me every now and then you'll get, like, in the real-time session, you'll be getting the Annie who will keep asking questions. You may have to answer. So here, like, map the following to the corresponding data types: XML files, email body, audio, video, images, to structured, unstructured, and semi-structured data. Okay, XML and email body, to some extent I can say it's a semi-structured data, right? And data from ERP, CRM, I can call that as a structured data. And data from audio, video, images, I can call that as a semi-structured data, sorry, unstructured data, because there is not going to be any structure within this audio, video, images, everything. And my big data world, whatever the framework I have, it can handle the unstructured data very well. Now let me put a scenario for you guys. Assume, like, you are having 100 terabytes of CRM data, ERP data. To some extent, we can make databases, like sophisticated database like Oracle, we can handle it. But can I analyze and handle the 100 terabytes of audio or video with any other database? I cannot. I need some mechanism to do it. Even if I'm going to do it with a different system, I need to transfer that particular data over the network and get things done. That's going to be even more difficult to do. Right? That's where the problem of how to transfer the data, how to solve this data transfer problem, and how I'm going to apply the data science or the algorithm in that particular area, that we will be saying it. Okay. So there are some reading materials about what is big data, everything. Now let me give you another scenario how big data space is being used in various industries. In various industries, how it is being used. For example, recommendation engines, ad targeting, the search quality, right? Everywhere. For example, assume, like, you're visiting some other country for web conference. After reaching the particular country, if you log in, most likely you may get an advertisement from Google saying whether you want to go to some Indian hotel or the hotel that you used to prefer in India, right? And whether you want to book a hotel there to stay, all such things, all such advertisements, more relevant advertisement from where you are accessing, what used to be your behavior, right? Everything based on that, it used to send the advertisement. It used to post the advertisement because it's going to be more relevant to post the advertisement to the individual which is relevant to them. Simple example, it makes sense to post an advertisement to a family where they have newborn kid, advertisement about a diaper, right? It makes sense. But it doesn't make sense at all to post advertisement about diaper to a bachelor, right? There, like, for him, like, if the person is interested about the mobile, it makes sense to give advertisement about the newly launched mobile or good offers like available for that particular person. That's going to give more more revenue generation model, or like the rate of income or the um, amount of investment, the return I'm going to get over the investment will be very high. Even like when you log into your LinkedIn or like your Facebook, the system will detect and identify who are all your friends, who could be your friends, the people you may know, all such things it will identify and let you know. Right? All such recommendations, all these things, they are using the big data technology. Okay. And in telecommunication, the amount of data that is getting logged across the country, what is the usage? What is the usage of data across the country in different towers? How the data is being used, utilized, all such things. Okay, the data we are talking about is like really, really, really massive, and I need to identify, is there any anomaly happening in the data pattern? Okay, um, is there any anomaly happening in the data pattern? Right. Okay. One question I see: how will the system know whether the user is a bachelor or with kids? Okay. Okay. I'll give you a very good thing that happened. You guys might have happened. This is where like the total turnaround story happened about the big data, the recommendation engine. Okay. About the target happened in, it came in Forbes magazine. The target, they were analyzing all the click pattern, the browsing pattern of each individual users. Okay, each individual users, how they are browsing, what page they are browsing, everything. Based on that, it was identifying the profile of the particular person. Okay, the probability of this particular person being a bachelor, the probability of this particular person having kids. Okay, what it is, and it will make a profile, categorize them into different groups, and it's going to send all the coupons or recommendations, other marketing materials items to those users, the relevant marketing material item coupons to those materials. Okay, that's where the data science comes into picture, grouping the right users in the right profile. Okay, that's where the data science comes into picture. What happened in Target? Based on the browsing pattern, it identified, okay, the user, the probability of the user being pregnant is very high, and it started sending the prenatal vitamins to that particular user. But unfortunately, it happened to be a teenage girl. The father of the girl got angry and sued Target, and they apologized everything. They mentioned saying it's a system, it's a machine learning technology, and the system does this categorization, everything. But what happened after 3 months? The person withdrew the case, saying like what you happened, what you said was true, right? And if you look at it, like system was able to identify, profile the person to the right place, like to the right extent, right? In the right profile, based on their the behavior, like what they are browsing. Assume like I am browsing like n number of movies. Assume I am browsing n number of movies in the Netflix website. Based on what movie I am watching, it can predict. That's called predictive analytics. It can predict what what is the type of movie I may like, and it will group the same taste users. Okay, all the users who watched similar such movies, and from there it will suggest, okay, you have watched like 10 movies, and I have also watched 10 movies, like all like a similar taste. And if you are watching the 11th movie and if you rate it as very good, there's a very good chance I'll also like that particular movie, because like we both share the same taste, right? The same way, that type of analytics it will be doing. That's called um, in data science we will be doing in machine learning. It's a clustering or like a recommendation engine development, everything it comes. In general, it's called predictive analytics. It's called predictive analytics. Okay, and n number of areas fields it can be applied. And here we are talking about a huge, massive volume of data. Assume like in Amazon or Walmart, what are all the products user buying? Okay, you may wonder why they are forcing us to have a separate card, a customer card, right? They can identify like what are all the products I am buying, what is the pattern with which I am buying, right? They can predict, okay, what I will buy 2 months down the line. For example, in Florida, they predicted whenever there is a hurricane, the sale of strawberry increased by multiple folds. Whenever there is hurricane, the sale of strawberry increased by multiple folds. They couldn't identify the reason, but thing is, they utilize that particular opportunity to increase the sale. So whenever they predict a hurricane about to come, they'll increase the stocks of strawberries in Florida. Okay. So these are like it's called predictive analytics. To do such a huge, massive analytics to massage or to identify the pattern with the huge volume of data, I need a place or I need a framework or infrastructure to handle such a huge volume of data. That's where the Hadoop, the framework which is going to come in handy and help us. The framework Hadoop going to come in handy and help us. Okay. Okay. Here in telecommunication, just like what is the probability the network may fail at this particular time, at this particular region? Okay. What are the things? Okay, those things we are going to analyze. Now you may ask the question, okay, the same thing we are doing it in the data warehousing. Okay, I'm going to put the question. Okay, data warehousing can handle. I have a separate slide to compare. Okay, separate slide to compare that. It can handle the structured data very well. It can handle the structured data very well. But when it comes to unstructured data, assume like I have huge images. Assume like the same sample I'm going to tell. I have horizon. There's the documentary. Okay, big data documentary. There's a BBC Horizon big data documentary. If you get a chance, like you can just have a glance through it. It talks about predicting the crime. What is the probability of crime about to happen in this particular area? Okay, they tried it out in few places in US. It worked out to be it worked actually. Okay, it worked. Imagine the amount of data they need to digest, the amount of data they need to process, and how fast they need to process that data. That's going to be really, really very huge. Okay. And when it comes to the unstructured data, the normal data warehousing technologies it cannot handle. I have a separate slide to compare it with what's happening with the data warehousing as well. Okay, and in it's used in the government side as well for welfare schemes. How the welfare schemes, what is the reach to the people, and very good example is Aadhaar, the usage of Aadhaar within India. And heaviest usage is in the healthcare and life science. Heaviest usage is in the healthcare and life science. Imagine if now the healthcare and the life science, it's like moving towards the side like earlier we used to get a medicine saying this medicine will be effective 90 percentage, it will be effective for this particular disease. For this people from this particular geography, it will be effective 90 percentage or like say 80 percentage. But nowadays they are moving towards the way of giving a customized medicine for each geography. If I give you a medicine, say like I am having some XYZ disease, and if I'm going for a medicine, the doctor will say this will be 80%, it will be effective. Okay, the amount of confidence I am going to get will not be that great. At the same time, if the doctor says this particular medicine is customized for you and it is 100% it's going to work because you are from this particular background, this gene and this particular geography, so it's going to work 100 percentage. The amount of confidence I'm going to get is going to be really, really very high, and the way I'm going to solve that particular issue over there is going to be totally different. Right? People are moving towards that particular area in the life science because I need to, in this area, I need to analyze and I need to handle such a massive volume of data. Massive volume of data, like huge amount of data, different parameters, n number of parameters. What is the pattern existing? Okay? How the people can be grouped? All such things I need to do, and that's the best place it's being used or it's being explored extensively. And banks and financial services generally it used to be the lagger. They used to be the lagger in terms of adapting new technologies, but all the accessory things they have used it. For example, I want to identify whether that particular transaction is a bogus transaction or not. Whether that particular transaction is a bogus transaction or not. The moment you swipe your credit card, based on the pattern, okay, your earlier pattern, what used to be your spending pattern, how much that you used to spend, okay, all such different factors it used to analyze, and it will predict whether that particular the probability of that particular transaction being bogus or not. What is the percentage? It will try to predict, and it will give a suggestion. If the probability is if it is very high, it will put a hold on that particular transaction and it will send an OTP, one time password, or it will make a call to that particular customer saying there is a transaction, it looks like totally different than your earlier trend. It used to send a message, is that really you making the transaction? Okay, is that really you making the transaction? So here, like the amount of transaction that's happening across the country at any point of time, it will be millions and millions of transaction will be happening. And based on the data that I get, I need to analyze with the millions and millions of data that's existing within my database, and I need to analyze in real time. I need to get the result very fast and I need to give the response. The amount of time I am going to get to give the response is very, very less over here. Okay, so here I need the speed. Or like assume the scenario where government want to identify if we increase the interest rate by 25 basis points, what will be the impact in the economy in the country or in the global level, what will be the impact? Okay. Whether that's going to create a chain reaction or whether the banks are ready to handle, whether our economy is ready to handle such situation. Imagine the volume of data that needs to be processed, analyzed, and to find that particular insight. It's going to be really, really very massive, right? So here we are talking about getting the real-time analytics in real time, getting the data in real-time world, and get the insights. And retail industry, again, like it's a huge place where like how I'll identify the customer churn. That is like whether the probability of losing that particular customer from my customer base. Okay, what is the probability? If I see this particular customer is not getting satisfied or like the satisfaction rate of this set of customers is going down for some reason, I'll identify the reason. I'll start sending some offers, coupons, everything to those set of customers to retain that particular customer. Anything if I find it well in advance, anything if I can find well in advance rather than after the incident happened, it's going to be really very advantageous in the business world. One scenario I'll tell you, there is something called, I don't know how many of you from Boston, there is something called street bump. The mayor of Boston, okay, mayor of Boston said, I have enough people to solve my problem in the road. There's like if there are any potholes, I can send people to fix them. I have enough people, but I don't have any technology or any mechanism to identify the high priority potholes, the high priority items that needs to be fixed, which is impacting the people a lot. Okay, I don't have any technology. So what he said, what he did, he went to a website called innocentive.com. Here, like if you have any problem, you can post your problem and you can give offer for your problem as well. Whoever can find a good solution for your problem, they can post the solution, and if you like and accept that particular solution, you'll be giving that particular offer to them. So he offered $25,000 for this particular problem statement, and two students from MIT University, they offered a solution by developing an app in the mobile. Okay, and they asked the mayor to ask their people to install the app in their mobiles. So what happened? Whenever the mobile starts moving, right? Whenever they are in the car or whenever they are walking, whenever it starts moving beyond some speed, it'll get activated. It'll start recording the GPS location and the vibration happening in that particular mobile. If they come across a pothole, there's a very good chance the mobile will vibrate, right? There's a very good chance the mobile will vibrate. Again, it will vibrate for the speed breakers. Or like if the user drops the mobile by mistake, it will vibrate. So all this data, it will get recorded and it will be sent to a cloud where like thousands and thousands of users who are using this particular app, installed the app in their mobile, it will start sending massive amount of data. Every day they'll analyze, massage this particular data and identify, rule out all the things like the data occurred because of dropping the mobile or like crashing the mobile somewhere XYZ. It will ignore, and it will ignore all the data occurred because of like the speed breaker or other things, or like once in a while it would have happened that might. So it will identify all the real data and it will group the data so that okay, which particular pothole or which particular problem in the road is creating a huge problem to the user. It will prioritize it and send the complete list to the corporation to the Boston where they can send people to fix it. And they'll send the people to fix them. And next day it can verify the data whether that problem has been really fixed or not. Right? Again, they're going to get the data. The system will verify and tell them, okay, the problem has been fixed in this particular area, and this is the improvement we are getting it. In the first shot, they could get almost like 60 to 65 percentage of data correct. In the second version, they improved it. Here, imagine the amount of data that they need to handle and the amount of data they need to process every day to segregate the real data and all the error data, everything, it's going to be very massive. And for all this, we will be using big data technology to segregate the data. When it comes to big data, it doesn't matter the form of the data, whether it is structured, unstructured, semi-structured, it doesn't matter at all. Okay, assume I am providing you guys with say 1 billion Twitter comments, 1 billion Twitter comments that happened yesterday. I want to identify what was happening. Is there any special incident happening yesterday based on the Twitter comments and what was happening? If I want to identify, really I cannot do it, right? But if I analyze the comments manually, to some extent I can identify, but again, analyzing 100 million comments manually is going to be really a very tedious task, right? If I apply the machine learning, the data science plus the big data in the cloud platform, I can identify the insights very quickly and easily. Within minutes or hours, I can identify the insight, what special incident was happening yesterday, whether I should concentrate in that particular area for my marketing or my sales activity, anything I want, I can do. Okay. That's where the volume, the velocity, and the variety, all three together, it's going to give me the problem, the solution for my problem. Okay. Now let's move on to the slides. Now we are going to solve the problem of DFS, distributed file system. This called wherever I'm going to store the data in the distributed way. Okay. Assume I am going to process 1 terabyte of data. I can process with one machine or like 10 machines I can process the data. If I have 4 IO channels in one machine and if each channel can process 100 MB of data per second, if it is going to take say 43 minutes with one machine, how much time will it take for 10 machines? Exactly 4.3 minutes, right? It's a simple maths. That's where we are going to use the distributed mechanism to solve the data. Now, we have talked about the three type of problems that's existing, distributing the data across multiple machines, distributing the work across multiple systems, right? Everything, as well as this transfer problem I'm going to come later. That's where the key thing going to come, the key differentiator between the data warehousing and the Hadoop framework. It's going to come into picture. We have a framework to solve this particular problem. That framework is called Hadoop. The Hadoop is going to help us to solve this particular problem of distributed environment. Whenever I say framework, let me just introduce you guys like what is a framework. Framework is going to give me the structure, the baseline underlying structure, where all the underlying problem will be resolved by the framework. I don't need to worry about the boilerplates or the underlying data. Say for example, you're constructing a building, okay, a shopping complex. While constructing, what you guys will do, you will make pillars and slabs first, right? Pillars, slabs, you'll bring in the power, you'll bring in the water supply, the drainage, all the basic amenities you will make it first. That's going to be the framework. Later, whether you want to convert that space, the space in the second floor, as a retail store for some garment shop, or like the space in the first floor as the retail space for the say groceries or fruits, vegetables, or like you want to make the fourth floor as the cafeteria. Okay. Any implementation you want, you can give that custom implementation in each space and each floor based on your need. However you want, you can do it. The same way here, Hadoop is a framework which will handle the distributed environment. I can say, okay, this is the amount of data. You store it in the distributed fashion across these 10 machines, across these 100 machines. It will handle it. You don't need to worry about how to slice the data, whether I am breaking the record or not. Okay. After slicing, how I am going to arrange the data back and get the data, all those things I don't need to worry. That will be taken care very well by the framework. That's the advantage of having the framework. Okay. As such, framework, the Hadoop framework works in the master slave architecture. It works in the master slave architecture. So what happens? I'll be having n number of machines distributed like this, say 100 machines or 200 machines everywhere. Okay. Uh, in our actual session, we used to discuss this for like around 15 to 20 hours. Okay. All this, the architecture, the way it works, how to do the programming, everything we discussed used to around like 12 to 15 hours we used to discuss. I'm just showing you guys the tip of the iceberg. It works in the master slave architecture. Master, and I'll be having a slave, a number of slaves. Assume I have a huge data. This is the huge data I have. I'm going to store this huge data, massive data into my cluster. Okay, so again, massive data into my cluster. Now, the system will take care of dividing this particular data into n number of pieces. What is the size? How it is going to divide? Everything will be taken care by the framework for us. We don't need to worry at all. Okay, it will say this is like the piece 1, this is piece 2. How to divide, how many slices, how many pieces to divide, everything it will be taken care internally. Okay, let's put this in the background. Okay, I have this huge amount of file and I have some algorithm to process within this particular file. Say I have a huge amount of Twitter information. I want to segregate all this Twitter information is about the Prime Minister of India, Narendra Modi, what people tweeted yesterday, okay, when he was in US. So around like say like a 2 million or 3 million Twitter comments were there only yesterday. I want to identify the sentiment, what people think about his talk, about his activities, whatever that he did, right? Yesterday, how many people, how many Twitter comments were thinking positively and how many Twitter comments like talking negatively about the incidents that's happened yesterday. Okay, that's a simple analytics I'm going to do. So this is going to be the logic, how I am going to identify him. Okay, based on the data science algorithm or XYZ algorithm, I'll have some logic. I If I run this particular logic or this particular small function against the Twitter comment, it can tell me whether it is a positive Twitter comment or a negative Twitter comment. Okay, but I have 3 million Twitter comments. I want the insights quickly. What it will do, it will while storing it into the cluster, it will decide how many blocks should be made, how many pieces it should be divided into. Okay, it will say I'm going to divide this particular. There are some strategies available. We will discuss about the strategy in detail in the actual session. On what basis it's going to divide everything. It will decide automatically saying I'm going to put the piece 1 in this machine, piece 2 in this particular machine, and piece 3 in this particular machine. At any point of time, it knows very well, okay, how these pieces are organized. Say for example, I have this file 1. This file 1 is made of piece 1 plus piece 2 plus piece 3. Okay. Yeah, I see some questions. What I'll do at the end, I'll go over the questions and I'll answer the questions. Yeah, folks. Okay. Now, I'll have only this information. This is called a metadata, information about a data, right? And I'll say piece 1 is available in node 1. I'm going to say call this as like say machine 1. Okay. This as machine 2. This is machine 3. After this particular concept, we'll go for a small break, 5 minutes break. Okay. So that I can have some proteins, vitamins, as well as you guys also can have small refreshment. A small 5 minutes break. Okay. So I'll have information saying P1 is there in machine 1. P2 is there in machine 4. P3 is in machine 5. Okay, all the failure handling, everything is available within the framework. Okay, all those things we will be discussing it in detail in the actual session. Okay, I'm just showing you guys the tip of the iceberg, the happy condition or like the good condition, good path we are discussing. So I'm going to say store this particular file F1 into my cluster, big data cluster. It will decide, it will break them into n number of pieces. Okay, it doesn't matter, it doesn't care whether it is breaking that particular data into n number of pieces. Assume like I have a huge zip file, I have a huge zip file of images, a set of images, 1 million images. I may get like some images in this piece 1 and some images in this piece 2. Some images may get broken across the machines, right? Few of the data of a particular image will be in this machine, few will be in this another machine. All this will be handled wisely by the framework. How it is going to handle? Okay, it's a number of things available, technologies like input split, a lot of stuff. Okay, So I'm assuming I'll leave everything to the framework. I don't need to worry over here. Okay, so it'll break exactly, it'll slice default. It considers as a 128 MB pieces. I can customize this size. I can increase or decrease this size very well, no issues. Okay, I can do it. It will slice them, divide them into n number of pieces, arrange it into different machines. It will identify which machine is having more resource to store the data, which machine is having more power to do the compute, everything. Okay, now comes the important piece. I'm going to say apply this particular logic on this particular file, right? And system knows the file F1 is made of piece 1, piece 2, piece 3. So instead of copying, bringing the data to my system, to my compute unit, right? In traditional world, what we will do, we will read the database, we will read the data over the network, right? And bring it to my compute unit. Now, it's going to consume huge amount of network resources. To avoid that, what I'm going to do, I'm going to send the logic, the copy of the code near to the machine where the pieces are existing. Because generally the logic or the program size will be very, very less, right? It's not going to be in GB, very few MBs it's going to be, right? Now, the data will be existing in the same machine, the logic will be executed. The same machine locally, the logic will be executed. Okay? So let's say it will get executed in the same machine. And it's going to give me the result. Each machine will give the results on processing that particular piece of data. Okay, how this piece going to happen, how it is going to decide the strategy, everything, like there's a huge list available. Okay, mechanism, it follows some strategy that we are not going to discuss now. In actual session we discuss, but not now. Okay, due to the we are going to have the session only for 2 hours, right? So it will get, each individual machines will get the data. My framework is going to consolidate this result. My framework is going to consolidate all these results from all this machine. Okay, as a single result, and it will give it to me saying maybe like say 85 percentage of the people thinking it positively, and 13 percentage thinking it negatively, and 2 percentage not able to identify. Okay, some information, some insights. Okay. So as a user, I don't need to worry about what's happening internally. I'll bring a huge amount of file. I should know what logic I am going to process on that particular file and what is the result I want. Based on that, I'll design my logic. In the actual course, we learn about how to design this particular program, how to write this particular logic. Okay, that is called a MapReduce programming. Okay, what is this map? What is this reduce? Different stages it happens, what they are, how I'm going to design. Okay, all those things we will be learning. This particular file, okay, whenever I store into the system cluster, whenever it's getting stored, right, breaking into a number of pieces, it gets stored in a file system called Hadoop distributed file system. We'll understand like what is this Hadoop distributed file system, what is the strategy being used to distribute the files, and how the framework going to distribute, and what are all the things I can control, the size of the piece, and what I should do if the record is broken across the piece, right? If the record is broken across the piece, how I am going to handle those scenario situation. And all of a sudden it could happen, one machine can fail, right? When the process is going on, when I have thousands of machines, one single system can fail, right? Some hardware failure, some XYZ, how the framework going to handle that situation, everything, okay, it's going to handle. Now the logic we will be using is, we will be using a Java programming. We'll be using the Java program, and the framework, within the framework it gives me a methodology called MapReduce to solve this particular problem. It's called MapReduce programming. Okay, and we will be using Java language here. Okay. And my master, again, like my master could fail. If I lose the master, I lose all the information on like what piece getting stored, how I am going to how I am going to address the situation. All those things we are going to discuss in detail. Okay, in the actual session. This is how the cluster looks like. Everything is going to be an abstract for the user. All the things that's going on, even if one system fails, how it is going to handle it. It wisely it handles, beautifully it handles. Because like if I have 5,000 systems, the probability of the systems getting failed for some reason, some physical failure, some XYZ, it's very, very high, right? And it's going to handle it wisely. All these things will be handled by the framework called Hadoop. Here, like the typical Hadoop cluster, I'll be having masters, the name node, active name node, secondary name node, standby name node, and a number of data nodes. With this is just a small sample configuration so that you can understand how a cluster looks like. Okay, there are the cluster sizes used to vary depending on your budget and depending on what problem statement you're trying to address. Okay, generally the this masters used to be a very high grade hardware, and data nodes used to be of low capacity hardware. It will have all the data, the actual data getting stored. The biggest difference I'll just quickly show you. The masters will have a huge capacity RAM, and the data nodes used to have huge capacity of hard disk because actual data going to get stored in the hard disk. And how what will be the size of this particular data node all depends on this amount of data you're going to handle in your business scenario. Okay. Now you may for example, CRs, they moved from Teradata, Oracle Exadata SAS to the Hadoop. The main reason for it being the type of data they want to analyze, the type of data they want to analyze. Even if it is like unstructured data, Hadoop can handle it very well. And the horizontal scalability, I can go to 2000 nodes or like 5000 nodes or 10,000 nodes. When I say machines, they all are machines. I can go to any capacity in Hadoop cluster, but that is not the case with Teradata or Oracle Exadata. If I want one simple example, what happened? The University of I think Library of New York, they had a huge number of scanned images of various old books. Scanned images of various old books. They want to digitize those books using the OCR software, Object Character Recognition software. They know this is the volume I'm going to handle, and the more the fast I do get it done, it's going to be more easy. So what they did, they went ahead with Amazon Web Services. They hired around 100,000 machines. They used for around 16 hours. So total usage is 100,000 into 16, so around 1.6 million hours, right? 1.6 million hours. Even if they pay $1 per hour per machine, they'll pay $1.6 million, and the complete problem or issues will be resolved, right? Within minutes, they'll establish the cluster, have that particular data analyzed, convert them. Whatever the images can be converted into the characters, they can do it and get things done. That's what they achieved. That's what they did. Okay, so this was the main reason. Okay, and Hadoop is not a replacement to the existing database. Hadoop is not a big database. Okay, let me make this one big disclaimer. Hadoop is not a big database. Database can handle the structured data, it can maintain transactions, everything. But here Hadoop is totally a different ball game. Here it's going to handle massive amount of data. It's going to do the batch processing. It can handle real-time analytics as well. There are some components within the Hadoop ecosystem available which can handle uh, real-time analytics as well. Say for example, we have something called Apache Spark. They claim this is going to be even more faster. It does in-memory computing. Okay. Again, this is not going to be a replacement to the Hadoop itself. Okay, it's going to coexist. Hadoop will coexist with the other technologies. It's not going to be a replacement. Okay. Slowly, like people will start using it extensively, and that will become the mainstream of technology. Right. Now comes the important discussion. Like this is where we are going to discuss how we are going to solve this, like why we are going to solve this problem of transferring the data. In general, this is how we will be having the infrastructure, right? In general, this is how we'll have the infrastructure. I'll collect extensive amount of data. I'll store it in the storage grid. My storage grid will have like a huge storage capacity, everything. I'll keep collecting the data, I'll store it. Beyond some limit, what I'll do, I will archive the information. So 90% of the data, I'll keep archiving it without doing any analysis, without finding any insights. Right? And I cannot process all the data. I cannot process all the data simultaneously because I'll not be having enough network capacity to transfer the data from my storage grid to my compute grid. My ETL compute grid will be existing separately. To do any analysis, I need to move the data, right, from my storage grid to the ETL grid. To move the data, I have to use the network. Network is going to be a bottleneck there, right? Network is going to be a bottleneck there. Because of that, I'll not be moving the complete data. What I'll do, I'll just pick some sample data, like say 2% or 5% of the existing data, do the analytics, do the analysis, and then extract the essence, extract only the insights, store it in the RDBMS, and generate the report. That's what I'll be doing it. All because of the limitations of the data transfer. If I'm going to transfer huge amount of data for one terabyte transfer of data, I'll take around 2 hours, right? 100 terabytes, I'll take 200 hours. So it's going to be really a huge amount of time. How big data comes into, how Hadoop framework is going to solve the problem? It's going to solve the problem doing the compute, by doing the compute near to the data. The compute is going to happen near to the data. So for example, data is lying over here, the paths, right? The file 1 paths P1, P2, P3 is residing in these machines, machine 1, machine 4 and machine 5. And I'm sending the program near to the data. I'm not moving the data. I'm not moving the data out of this machine over the network or anything. Do the analysis. The insights from this piece of data will be calculated from this machine, and the insights from the part 2 will be collected from the machine 4, and the insights from part 3 will be collected from machine 5. I know surely like most of you will have questions like, what if the data is broken, right? What if the data is broken across these machines? Those things is going to get handled wisely by the framework for us. Okay? That's what we are going to learn in the actual course, how things will be handled, how the records will be handled even if it is broken physically across multiple machines, how framework is going to handle, how we are going to leverage that we are going to learn. And all the data will get consolidated. I'll be using this particular data. Now, in the earlier, the traditional way, I am not analyzing the traditional way, I am not analyzing the complete data. Since I am not analyzing the complete data, I will not be getting the complete insights. I'll not be getting the complete insights. But here, in the big data space, I am not going to have separate grid for compute and separate grid for the storage, right? Both going to exist together. Wherever the data is stored, the same place I'll be doing the compute. The compute is going to happen near to the data. The compute is going to happen near to the data. Because of this, I'll avoid archiving. I'll not do any archiving in the big data space. I'll keep increasing my storage grid, and that will have the compute capacity as well. And for the backup, I'll be maintaining 3 copies of data. For example, here, this P1 will be maintained in 3 different machines. The copy will be maintained in 3 different machines. P2 will be maintained 3 different machines by default. I can increase this number or decrease this particular number. I can very well do it. Okay, everything I have a full control in the framework. Everything I have a full control in the framework. By distributing it, the biggest advantage I'm going to get is, even if one machine fails, assume the machine which is processing the part 2, if it fails, decide, okay, the machine 4 failed, which is processing the P2, it will find which machine is having the copy of P2. It will send the program near to that particular machine and get things done. Same thing like how we execute things in a project in IT industry. right? If I'm doing a project with the 5 software engineers, if one software engineer quits the organization and goes, just because of that, I will not halt my complete project. I'll find someone else who can do the same job, who knows that particular technology, assign that work, get the job done, right? The same mechanism it works. All these things happens automatically within the framework. Okay? All these things happens within the framework. So the failures and handling it wisely, everything is done by the framework. That's the beauty of the framework. All the boilerplate, all the basic things will be done by the framework. So here I will have the capacity or capability to analyze the complete data, so I can get the actual insights, the complete insight I can get. The storage and compute going to coexist. So let's take a small quiz, small question. Let me just take. Hadoop is a framework that allows for distributed processing of in general. This is for the large data sets. Even if we give a small data set, it is going to work. It's not going to say no. Okay. This is something like Hadoop, but with the small data set, we will not be in a position to measure the performance, how it is behaving, everything. But it is going to be useful to learn that particular technology. While learning, what we will do, we will be using a virtual machine. Okay, everyone will be provided with this virtual machine. There, all the installations, configurations well done. You can run this machine in your laptop, so that like this is like a flight simulator, right? Assume you are going to learn flight, flying a flight. Everyone cannot offer to buy a flight, right? But everyone can offer to get a simulator. So everyone will be provided with simulator. Once you become comfortable, right, everything, then we will be going ahead with the actual flight, flying in the actual flight. This is like a simulator. It's called a virtual machine. Everyone will be provided with this virtual machine. Okay, and this particular virtual machine, I'm going to do a small sample. Okay, running a small sample. Again, like in the actual session, we used to discuss in and out, right from the ABCs, the basics to the advanced concept we used to discuss. I'm just going to show you a small sample. What I'm going to do, I'm going to have a small text file. Okay, a small text file. I'm going to count each word how many times occurred in this particular file. Say for example, the how many times it occurred, dust dot how many times it occurred. Okay, so I'm going to do a small analytics. You may wonder like this is a small algorithm, but this particular piece of logic, counting the number of words, frequency, what is the frequency each word is occurring, that's used extensively in any text processing, identifying the sentiment of the Twitter comments, right from the sentiment of the Twitter comments, or like even Google uses this algorithm to search to give the relevant document to you. Whenever you give to give the relevant document, there are a lot of algorithms internally available. For to run most of the algorithms, you need this particular number. Identify each word how many times occurred in that particular document. So this is the sample program I am going to run. I am going to identify each word how many times occurred in this particular file. So this file I have added in a file system within the Hadoop VM. It's called HDFS, Hadoop Distributed File System. And internally it will decide how many pieces to make everything. Since it's a small piece, it's having as a only one block. And in the actual session, we will discuss about handling even a bigger file, like for example, the XMLs from the comments about each website, the comments from each multiple websites, right? This is from a website called Reddit. It's going to collect the comments, feedback, rating about multiple websites. It's going to collect. That has been downloaded. One sample has been downloaded. I'm having like what all category that particular website belongs to, what are all the comments I have about this particular website. And this is a size of almost 504 MB, right? Almost a half a GB. And I have internally like it splitted into 4 blocks. Why 4 blocks? How 4 blocks? That we'll be discussing in the actual session. Okay, let's assume this has been broken into 4 blocks. So internally, while processing, each block will be processed individually, and the results will be consolidated, and that will be provided to the end user. So for our understanding purpose, let's consider a small file, fearnomore.txt. I'm going to identify each word, how many times occurred within this. For that, I'll be writing a Java program, okay, a small Java program. This is the Java program, okay, and it has two parts, right? All the configurations, map, what should do in the map, okay, what should happen in the map. This is the map logic. What should happen in the reduce logic, okay, and how to design, how to write this map logic, how to write this reduce logic based on the problem statement that I have, how to design. That's what we are going to learn in the MapReduce programming course. That's like in the actual big data course. But here, let's assume I have the Java file. What I'll be doing, I'll compile this Java file. I will take it, I'll make it as a jar file. Then I'll be giving it to the Hadoop cluster saying use this particular logic, use this particular program, right, to process the file that I have here in the VM, fearnomore.txt. Okay, so how to bring this particular file into the file system, that is distributed file system, Hadoop distributed file system, that we will learn later. But now assume the file is already existing within the HDFS, Hadoop distributed file system. Okay, now I'm going to issue a command, a simple command like this. Okay, Hadoop jar, that means execute this particular jar file logic. So execute this particular logic in this particular location. I have the jar file. Hadoop default it comes with some jar file. I'm going to say this is the input. Fearnomore.txt is the input, and where the output should get stored. I'm going to say store the output in this particular location. This is how I'll be triggering the program in the cluster. Once if I give this, what's going to happen? This is the first part. First, I'll store the file into the cluster. It will get distributed into a number of systems. Any backup, everything will be taken care internally. It's going to be there. Now, if I say like run this particular logic on this particular file, okay, all those things is like it's hidden inside. I'll not bother. I'll say this is the input file location where the output should get stored. And what is the logic? The logic I have written it using the Java program. Okay, in and out of it, we'll be discussing it. What is this long writable? Why I am overriding a method map? Okay, and what is this key? What is this value? What is this context? Each and every term we will be discussing it in detail. Okay, in actual course, almost like around 6 to 9 hours is dedicated only for MapReduce programming. We will understand the ABCs to the advanced programming. In the actual course, we will do even one advanced programming like processing or handling images as well. For example, we will do how to identify the unique images across this list of images, right? Visually, I can say there are three set of images available, but even if one small pixel gets changed, is changed within this particular list of these two images, right? I've got blurred or something. I'm going to run the MR program and identify. That's the advanced programming concept. Okay. All right. Going back, I'm going to run. So it will distribute the program in all the machines, and we will learn one other concept called how to do a join. Assume you have a huge data set of transaction information and customer information. You want to do a join, how to do it. That will also we will be learning it. Okay. All right. So let it run. It will take around a minute or so because it's a small file, right? But don't try to multiply it for a small file. This particular file is taking 1 minute for 1 KB file. So 1 MB it's going to take 1000 minutes. No. Okay. We cannot measure the performance of a flight just by flying for 3 kilometers or 2 kilometers, right? That's not possible. So, and we will understand in actual course what this output means, everything. Let's go and check the output. So output I gave a location, output batch corp, right? I gave slash output slash batch corp test out one. So I have test out one. Here's where the output, what this success, everything we will discuss later. This part R. Here in that particular file, I have two words all. One word with and, four word with fear. right? 6 word and, right? It's, I have not given the case insensitive, so it's case sensitive. So this is how everything has been split into, and this is the word frequency it occurred. Okay. Now, Hadoop as such, it's made of like a different components. We call that as a Hadoop ecosystem. Okay. Whatever that we discussed is these three components. HDFS. Yarn is like an operating system for distributed environment. How to handle the different resources, right, of different machines. That's done by the Yarn. And the MR framework is the one that we discuss now. On top of MR framework, there are multiple components evolved. The multiple components evolved, right? For example, Hive, everything is written like a statement like this, SQL statements, right? I can give like select star from this particular data set where this particular column value is equal to this, and then do a join with this particular statement. All the input that I give is very similar to the SQL statement. Okay, all the statement will be like a very similar to SQL that was developed by Facebook and contributed to Apache Foundation. One moment, folks. A similar way, there's another component developed by Yahoo called Piglatin. Okay, it's a data analysis component where we will give all the instructions like English like language. Okay, English like language. Now, when I show this particular Java file, people from non-Java background will take a back step. Okay, saying, okay, am I going to learn such a complex language programming? Is it necessary I have to learn this Java and then use this particular Java to do the or to solve the problem in the big data world? Right? The answer is no. Okay. The same question like happened, or the same question was raised by multiple employees within the Yahoo, Facebook, everywhere, because Yahoo had huge number of data scientists who are not good at Java at all, or who have never used Java. That's where they were forced to develop this particular component like a middle tier, right? Big. Okay, they'll be giving like English like language, load this particular or read this particular file, identify the unique records, pick only the IP address, and filter the IP address only from US, and sort it in the ascending order. All this English like language you can give, right? They use a language called Pig Latin, and the same thing like a Hive. They developed an intermediate component where you will give the input like a SQL like statements. You can write queries um, by joining two set of data, everything. But the biggest advantage is both Hive, Pig, everything. It's going to leverage the MapReduce. Okay, at the back end. Okay, at the back end, it's going to generate this logic for you. Generate this logic for you. Say, for example, you have Pig. It's not going to generate the Java code. Okay, like reverse engineering, but it will generate the instructions so that the computer can understand. Okay, not the Java code. It will generate this logic based on the instructions that you are giving. The input to the pig will be the pig Latin language. And pig Latin language is easy for anyone to understand. It's like English like language. Even though it's a new language, people can learn it with a short duration. They can learn. Okay, so I'm bypassing writing this particular code using the Java program and learning the Java program. All such things I am bypassing. And this particular component we will discuss like in one module is dedicated for Hive, one module dedicated for Pig Latin. The same way there is another component existing called Mahout, which does the machine learning. Okay, which does the machine learning algorithms. This particular course, the Hadoop big data, like we will not learn about it. There's a separate course available. The course path I'll explain it separately. Okay, down the line. And there's another component called HBase, which is a NoSQL database offering within the Hadoop. And I have Apache Uzi. I have a number of components. Okay, what I may do, I'll get the data. Say, assume like 15 terabytes of Twitter information I have got. First thing I'm going to verify and filter out all the good data. Okay, I'm going to remove all the error data. Then I'll run some analytics, identify some sentiments. Then the output of it, I'll take it to another job. Assume the first job is going to take around like 4 or 5 hours. The output of it, I'll take it to another job. It may take around like say 2 hours. Then I want to take that to some other RDBMS. I want to export that to RDBMS. I don't want any person waiting for the result. Once the result is available, take it to the next system and then do. Right? It's very similar to the AutoSys. Right? It's offered within the Hadoop ecosystem where I can connect multiple components and I can create a workflow. That component is called Woozy. The component is called Woozy. And after this yarn, okay, yarn is yet another resource negotiator that is like operating system for distributed environment. There are a lot more technologies evolved like graph processing, message passing interface, lot more components evolved, okay, which can leverage the cluster to do the distributed computing and get things done. Okay. And the HBase, as I said, it's a NoSQL database offering where you can store huge amount of data in a distributed environment. NoSQL is a totally a different terminal, different technology by itself. We are going to distribute the data, store the data in a distributed environment, and get the problem resolved. And to bring in the data, we use two different components called Flume and Scoop. Flume to bring in the streaming data, and we will be using Scoop to bring in the structured data from RDBMS. The same way we can use Scoop to send the structured data out of the Hadoop ecosystem to some other RDBMS. After analyzing, assume I have identified the sentiment of the Twitter comments about Modi on which topic or which item people think positive, what is the percentage, all this information I have analyzed, I have extracted the information. I want to take it as a structured data out to some other database. I can use a component called Scoop. All these components together is called Hadoop ecosystem. Wherever you say like people say Hadoop ecosystem, HDFS, Yarn plus MapReduce, these three components together is called the Hadoop framework. The Hadoop core, the framework has these three components, and most of the components comes from Apache Foundation. Okay. And there is a page called Powered by Hadoop. Here you can check what are all the companies using Hadoop, how they are using it, everything you can analyze. It's not limited to only this particular list. Whatever the organization voluntarily they came forward and listed, they have it's listed over here. Whatever the companies who came forward voluntarily, it's listed over here. From there, one copy or one sample for the Facebook has been taken. Facebook they revealed saying they are using two major clusters, one with 100,000 machines, another with 300 machines. For what purpose? How they have not revealed it. Okay, they may be using like even more powerful cluster or like some more clusters, but this is what they have revealed, and it has been taken provided as a sample. And as I mentioned, Yarn. Yarn was introduced in Hadoop generation 2. Within Hadoop, we have two generations, generation 1 and generation 2. Generation 2, we have got this component called Yarn. Okay, Yarn is like, assume in simple way, it's like an operating system. In DOS, we can do only disk operating system, right? But if I have Windows, on top of Windows, I can install anything I want, say Visual Studio or Microsoft Office or any games, whatever that I want, I can install it on top of the operating system. And all the resource management, that is the memory management, hard disk management, everything will be taken care by the operating system. On top of it, I can use the software. So I don't need to worry about the resource management. The same way, Yarn takes care of the resource management of the distributed environment. Okay. On top of it, I can have different technologies like graph processing, stream processing, um, or like in-memory computing, anything. There are huge spectrum of technologies available which can run on top of Yarn. Yarn, as I said, it's an operating system for distributed environment. If I have 4,000 machines, Yarn will take care of managing all the resources of these 4,000 machines. I'll say do this in-memory computing in this cluster. That's what I'll be mentioning. I'll say what to do, right? All this technology will describe what to do and how to execute it in the distributed environment. That will be taken care by the framework and Yarn. And as such, Hadoop, it has like three different modes of execution: standalone mode, pseudo distributed mode, and a fully distributed mode. We work in a mode called a pseudo distributed mode. The VM that we, excuse me, excuse me, the VM that we use, it runs in a zero distributed mode. So all the components, all the daemons, okay, for example, Edureka, if I try to see the Java processes, everything is a Java, everything is written using Java. There are n number of daemons running, as it's running as a daemon in one single machine itself, right? For example, if I want to test a database, if I'm developing an application with the database, every one of us will have a small database running in our own laptop or in our own system. During the development, we will test it out. But the real database in production, when it is going, the same algorithm, same logic, we will deploy it into the production and it will work. Right? The same way we are going to use here as well. So there are three different modes going to be there: standalone, zero distributed mode, and fully distributed mode. Fully distributed mode is the actual production mode where all the machines are physically distributed across multiple machines, and that's going to be the actual production cluster. Standalone mode is like everything going to work without the distributed file system. Only the logic we will be using it, but this we will not be using it in our actual learning purpose. But in case if you want to use it for debugging everything, we can use them. Okay. As such, learning path, there are different technologies, spectrum of technologies available. Okay. Hadoop and big data is going to talk about this what part of it. Okay. More details on the standalone and pseudo distributed mode. In standalone mode, everything runs as a thread. Everything runs as a thread in a single JVM. You will not see the daemons. Daemon in the sense like it's a process, continuously running process. In pseudo distributed mode, they all will be running as a process. And in the pseudo distributed mode, we will be using a file system called HDFS, Hadoop Distributed File System, dividing them into a number of blocks, everything. But in standalone mode, you can use the local file system, local operating system's file system to store the data and to read the data. Yeah, this is something like even though you need to use the Oracle database, what I can do in the middle layer, I can make small tweaking and um, I can use Access file or some other database only for testing purpose, right? Or I can use even a small standalone file for testing, right? That way. Okay, that's very. I just explained the tip of the iceberg, the difference in very short. Okay, all right. So if I check the various things available within Edureka, as such, like as a developer, okay, those who are comfortable with any languages like Java, Python, Ruby, and if you thing is about doing the programming, everything. Okay, we'll be learning about the Hadoop and big data. Here we will learn about how to do the programming, how to write this MapReduce code. Okay, of course we will discuss about the architecture, but we will discuss about the architecture and the administration part in a very small level. Okay, the main concentration would be on doing the programming. What is the MapReduce, everything, and a separate course like Apache Spark and Scala. We will understand about what is this Spark framework, how it is going to be useful for us. And Scala is just another language like Java. Scala is just another language like Java. Like that, we have Apache Cassandra. Cassandra is a NoSQL database. Okay, what it is, everything. If you are from administrative administration background, there's something called Linux administration and Hadoop administration. Hadoop administration going to talk about how I am going to establish like those 100 machines or those 200 machines, and how I'm going to get things done, how I'm going to establish the security among these machines, how those machines going to communicate with each other, how to install, how to configure, what are all the things I can control and configure. All those things we will be learning it as a part of administration. And data science part is going to, and we will learn in the administration, we'll learn about the virtualization, the cloud technologies, everything. Okay, and data analyst as such, they'll be talking about the data science. What are all the algorithms existing? What algorithm to use at what situation? Okay, how to leverage those algorithms? All those things we will be learning in data science. There is a language called R. R is an analytics language. Okay, like it's very similar to MATLAB. You guys would have heard about the MATLAB in colleges, right? It's very similar to MATLAB, where you can do some modeling, predictive modeling, or you can do some analytics, a number of algorithms. You can just say, do this particular algorithm on this particular data set. You don't need to worry about implementing that particular algorithm. Okay? And talent, data visualization with Tableau, that's how it goes for the data analyst. Okay? This is how it things goes. And as such, the certification path, okay, as such in the certification path, um, it's a live course, okay, it's instructor based course, and generally what we will do, we will have like one-to-one interaction in the classes, like any doubts, clarifications, because the number of attendees and the um, instructor ratio will be less, so that we can have individual attention, and every class will get recorded and it will get added to the LMS. We will be having 24 by support, and every module will have quiz, everything. Further details about this particular course, everything, you can get in touch with the support team and you can get it. And you will be doing one real life project. After completion of this particular project, it will be reviewed and you will be issued with a certificate. Okay, that's how things goes. And there are lots of blog material available which you can make use of to read what's going on, what are the things will be covered as a part of what that particular technology is about. Those things you can verify, and you can the email also, it's available, the downline, the bottom, anything you want, you can contact. Okay, so this generally we used to have an assignment. Okay, this is what this is a very simple, the basic assignments. Generally it used to be like a programming, and the solution will also be provided with you guys. Okay, and we used to collect the survey at the end of each course. Okay, you guys can fill in the survey, like what you think, what you have thought. If anything, like any questions, clarifications, you can put it in the comment section. The support team will be in a position to get back to you on any questions or clarifications. Okay, now I'm going to let me go over the questions. Like I saw a few questions like people posted. Let me go over the questions. Okay, and any questions you guys have, like please do post it. I'll just go over the questions. It may not be possible to go over all the questions. Let me just spend some time to go over the questions. Okay, all right. So I have a question. Okay, can a system differentiate among different images and how? Question from Deepak. Yes, that's where the data science algorithm going to come, Deepak. How we are going to make the system to understand. Okay, there extensively we will be using vectors, matrices that we learned in our 11th and 12th grade, right? Those things we will be using, and there are some proved algorithms already available how to use, and implementation available in languages like R, Mahout, it's available. We can use that. Yeah, Deepak. Okay. A question from Surinder: is big data also help to reduce the size of the data? Is it also help to reduce the hardware cost? Okay. Um, if you're looking at like just reduce the size and then find the insights, yes, it's going to do. But generally, what we will do, we will not destroy the actual data. If I want my other data scientist wanted to do some other different type of analytics on that particular data, we will go ahead and do it. With the cost going down drastically for the cloud, the data storage cost or the processing cost. Okay, the storage cost is like it's very negligible nowadays, because the actual data is going to be the business for me. For example, for Google, Amazon, the actual data that in the past 10 years or 5 years, what was the shopping pattern of different users from different history, different geography, that's the asset for them. All of a sudden, we cannot say, okay, I'm going to establish the company organization now and I'm going to use the big data, right? Data is going to be the wealth. I should have the data, like history of data, I'll be using it. So it's not about reducing the hardware cost, but of course, Hadoop is designed to run in the commodity hardware. Even if it is a low quality hardware, if the hardware fails, the framework can handle them wisely. Yes, Surinder? Okay, I have another question. So if we are using Google search, then our searches get stored in the search history. Then according to that history, Google will be showing me some results. But if suddenly start using the search engine, then it's of no use. Yes. Based on the pattern, I need to assume, like I'll give you another analogy. That's a question from Gaurav. assume like I'm going to have a sensor of the power consumption of an AC air conditioner across the organization. Okay, assume like I have tied up with a organization AC provider. I'm going to fit a sensor in that particular AC. I'm going to collect the vital informations of power consumption. What is the temperature? How much is the output? What is the compressor? The heat it's generating. Some n number of factors. Okay, I'll keep logging the information. While analyzing, I can predict. Okay, it looks like a pattern is getting generated where the AC going to fail in the next 1 week time, or like not only AC, any huge high cost machine. Okay, in the industry, in the mining industry, or anywhere. Looking at the pattern, I can predict. Okay, there is a pattern getting generated where the machine going to fail in the next 1 month time. Immediately, I'll send the management team or like a maintenance team to find out why that particular pattern is getting generated. Maybe the stress on the bearings or like less oil, some XYZ reason could be there. Okay, that's where we are going to do. But how to identify that particular pattern, that has to come from the data science, as well as I should have a robust mechanism to handle such a huge volume of data, and I need the data. Here, even though the things have not occurred, even before occurring, we are predicting it. Right? That's the predictive analytics comes into picture. I have a question from Shiva. Okay, that can be done using data warehouse. Then why Hadoop? Yeah, I hope this question would have answered. Data warehousing, we are going to talk about the history, what happened in the past with the structured data. Hadoop can handle unstructured data as well, along with the structured data, and we can integrate. Okay, the architecture called, you guys would have heard it, it's called Lambda architecture. Okay, it's called Lambda architecture. What we will do, we will bring in, okay, speed layer and the batch layer together. Okay, let me just okay, speed layer, batch layer, and service layer, where I'll bring in all the data together. What the in history, what happened, and what is going on now. The mix and match of it, I should be in a position to predict what's going to happen in future. That's where I'm going to win the race in the current business scenario. Right, Shiva? Okay. Okay. Question from Tinku. What kind of algorithm going to be considered while grouping and doing prediction? There are huge number of lists available. Okay, the Wikipedia itself, it um, it gives like a huge number of methods like algorithms. It's a huge list. But within data science, the very famous and like the algorithms like clustering analysis and uh, a number of such things, we will be learning it as a part of data science. What and how that works, what we are going to do. That think. All right. Okay. Question from Samir. Is it good for batch processing or real-time analytics? It's both. We have components to do both batch processing as well as real-time analytics within the Hadoop ecosystem. Okay. I'm going to say both. Question from Gaurav. How will it decide in how many clusters it will divide the data? Okay. So I guess like your question on this, how it is going to slice the data and store it in what system, everything will be taken care, decided by the system. What is the size of the block and how it should store, in which machine it should store, how many copies it should store. Everything can be configured and everything can be controlled. Yeah, Gaurav? Okay. Question from Amar, what is the strategy to break the file into pieces, size, etc.? Yeah, it depends on the type of analytics you're going to do, and depending on the size, the number of pieces, the size of the piece, how you're going to process, the there's going to be some impact both positively as well as negatively in the different systems, in the master as well as in the worker node. Okay, based on that, we will be doing it. Okay, that we will discuss in detail in the course. What's going to be the strategy? Okay, how I should decide the size, what I should keep it as a default. Okay, all those things. Okay, question from Amit. Logic is written in some programming language or framework dealing it itself. We'll be using a Java program, okay, for MapReduce. And for Pig Latin, we will be using a language called Pig Latin. And for Hive, we will be using a language called HiveQL, Hive query language. That looks like a SQL, and Pig Latin it looks like a very similar to English-like language. Yamar, Amit, okay. And the question from Gaurav: if we are not analyzing the whole data, then we are not getting actual results, and even sometimes we can get incorrect data. Is it? Yes, exactly. That's the drawback of doing it with the data warehousing, where we will not be considering, where we will not be in a position to consider the complete data. Right here, by sending the data, the logic near to the data, I'm avoiding the transfer of data over the network and getting things resolved. I'm with that we are going to get the power of analyzing the complete set of data. A question from Sridhar: what if there is a dependency of data in files? On what basis we will be distributing the dependent data? Data can exist in n different machines. Okay, even if it gets distributed, the dependent data is distributed across multiple machines. We will be mentioning it in the logic how it is, what are all the dependent data and how they are dependent. And distribution, it will be handling it by the framework. Okay, so the framework knows how the data is distributed, how to handle them. That framework will be handling it. Within the logic, I'll mention what data, how it is distributed, what are all the dependent data. Okay, not what how it is distributed, what are all the dependent data, I'll be mentioning it in the logic. Ashita? Right. Okay, question from Vikram: in what way big data and Hadoop is useful for business analyst? Okay, thing is volume. The best thing is my best answer is going to be volume. It can handle huge volume of data and can handle huge amount of data that's coming in. And we have um, components like Pig and Hive, right? Where like you don't need to learn about the Java programming, which is going to be more easy to give the instructions and get the things resolved. Here we are going to get the problem resolved in a distributed fashion and sending the logic near to the data. Yeah. Right. Okay, Tarun, in this increasing security conscious world, what are the regulations on big data? Any separate guidelines or similar to small data sets? Yeah, the same thing, whatever that is applicable, it will be applicable over here as well, right? If it is like it's a government information and if government of US says our data should not go out of our country, it should exist within our own soil. Of course, you have to have the cluster within US and the data should be stored within that particular cluster. And if there is any regulation saying like all this personal information should be stored in the encrypted form, even while storing it within the HDFS, we should store it in the encrypted form. While processing, we'll unencrypt, we'll decrypt, and we'll process. Okay, same thing it's applicable over here as well. Ankit, would be great if you could provide this PPT PDF after the session. The session will get recorded and the support team will be in get in touch with you guys, okay? Or get in touch with the support team. They should be in a position to share. Yeah, Ankit. All right. Joseph, what are all the major players in big data segment? Okay. If you ask, there is like as such, there are service providers. For example, Hortonworks, Cloudera, Mapr, okay, and IBM also recently they started. All these are like service providers. What they do, since we have spectrum of technologies, right? Spectrum of products within the Hadoop ecosystem, they're going to bring in all these products together in a single spectrum. Okay, all these products and they're giving it as a product, and they give professional level support because most of the product are open source. It's available open source everywhere, but thing is, they're going to give maybe what's new product and what's new. They bring in all the spectrum of technologies, various versions, everything in a single umbrella, and they'll be giving it as a single product. And they enterprise can take professional support from them. But this product assets, it's a open source. Even you guys can download and you can start using it. Okay, all right, it's open source, anyone, it's free for anyone. Okay, how can we manage the spatial data? Okay, the geospatial data, right, Gopinath? Here, there is something called spectrum of NoSQL databases. We'll be using different NoSQL databases, which is going to solve your data structure, and we will be doing it. Okay. Question from Arun Anand: what if name node goes down? Okay. So we discussed only the, I remember, as a master. I know name node is a master. There are some backups available like active name node, secondary name node. Each does its own each created for its own purpose. Okay. They are going to act like a backup. One going to act like active backup, another going to act like a passive backup, and it's going to get the problem resolved. Okay. Um, Shiva is Hadoop supports backup using tapes. That's going to be at the hardware layer, right? So as such, Hadoop, it will have the data in the hard disk. It's going to store the data in the hard disk. In each individual system, it's going to store the data in the hard disk. And from the hard disk, it's the responsibility of the administrator to take it to the tape if you want everywhere. But generally, that will not be required because I'm going to maintain multiple copies, right? Even if one system goes down, I'll be in a position to take the data from the other system. Okay, right. Now, um, okay, question from Abhishek. Is this correct to say Hadoop core system is just about data distribution and processing? Yes, that's a wonderful um, statement, Abhishek. It is correct. Big data, the Hadoop is going to talk about how I am going to store huge amount of data, how I am going to process huge amount of data. That's what we are going to talk about in Hadoop and big data world. Okay, all right. Is there any other program except MapReduce program? Um, like graph processing, MPI, all are different methodologies. MapReduce is a different methodology to solve the problem that was submitted by Google. The same way we have different methodologies and algorithms. Okay. All right. Question from Abhinit. I am from other domain, never worked on Java or other programming languages. Do you still recommend my type of professional to go for Hadoop? Within Hadoop, as I mentioned, we have different technologies which can be used by people from non-Java background as well. Okay. But in actual course, we will understand about the MapReduce program using Java, and there's a complementary course available within Hadoop, within Edureka to learn about Java, everything. Okay. Support team should be in a more better position to make yourself comfortable and choose the right course. Yeah, Binit? Okay. Okay, let me pick almost like I've reached the time. Okay, let me the other questions like the support team will be saving it and they'll be sending across the response. Okay, let me pick two more questions. Um, okay, is it possible to run structured data and unstructured data at a time? Yes, and within the cluster, it's not one single processing going to happen simultaneously. If I have 4,000 machines, right, n number of users will be submitting their job parallelly, so all those jobs will be happening in parallel. I may have thousands and thousands of files stored in the cluster. Assume this like a supercomputer where the compute capacity is distributed across multiple systems. I'll give the job, the systems, the cluster will get the job done, and um, okay, it's going to get things in the distributed environment, and n number of jobs going to happen in parallel. Okay, all right. Okay. Right. Um, Question from Vikas. Hadoop makes at least three copy of all the data. Means Hadoop is making already big data to bigger. Yes, it is. I'm going to, if I 1 terabyte is the actual size of the file within the system, it's going to store it as a 3 terabytes. It's three is just the minimal number, default number. I've seen in production where people going up to 5 copies. One copy will be totally managed in a totally different geographical location. right? In any case of disaster, at least I'll have the data, because data is going to be the asset for the organizations, right? Data is going to be the asset. Okay. Right. Question from Rakesh: can we integrate different Java framework like Spring, Struts, Hibernate with Hadoop? No, they all are like Spring, Struts, Hibernate are like a web framework, right? They all are web framework. This is the framework to handle for the processing, data processing. Right? You can bring in. That's where like this Lambda architecture going to come into picture. I showed you Lambda architecture, right? So the struts, Hibernate, everything will come in the speed layer, or in the servicing layer it will come. That that particular layer is going to integrate the speed layer and the batch layer. The Hadoop will be serving mostly in the batch layer. The speed layer we will do the real-time processing, and it has some components to do the real-time processing as well, right? Okay, I see huge. The other questions, like I'll ask the support team to send across the query. Okay, in case if you guys have still further queries or anything, don't hesitate to get back to the support team. And if anything specific to be answered, I'll ask the support team to reply to the questions as well. Okay, all right. I hope the session was informative, and it's useful as well to get an awareness on what Hadoop, what is big data, what is how it fits in the current world, okay, how it works. I hope it was informative. Okay. Any questions, clarifications, please do get in touch with the support team. They should be in a position to help you. I wish to answer every question, okay, but thing is like since like others have the other commitments, everything, I'm just will get completed this particular session, and I'll ask the support team to reply to your queries, right? Okay. The PPT and this particular the video, it will be shared by the support team. They'll be replying back to your email. The support team will be doing it, and the Edureka is supported by 24/7 support, and any query you raise through the support team, they will be definitely replying to it. Okay. All right. Okay. Thank you guys. Have a good day. Good night.